So I'll mention, I think you can maybe full screen. You should, yeah, that's great.
Okay, thank you, Jeff. Yeah, so thanks for that very kind introduction. And we'll see, my dog is joining us here today too, allowing her to stay with us. So hopefully she won't start barking. Yeah, and please feel free to ask questions along the way. And Jeff or Vivek or whoever, speak up if there are questions that pop up in the chat window, because I don't always notice them once I get going and start talking. So I thought I'd talk today about some of the work that I've been doing in my group for the last 5, in some cases 10 years, mostly the last 5 though. And that's on trying to identify affective events and also tap into the reason behind the polarity for the events. So let me give you some background here. First of all, you probably haven't heard the term affective event before. Affective is a term that ties into psychology and has to do with emotional states. And I've done a lot of work in the past on trying to recognize and extract information about events from text, and also trying to recognize emotions on text. And these are, for the most part, fundamentally different things. There's events and there's emotions. But the reality of life is that events impact people. And when someone experiences an event, we often infer an emotional state based on the fact of the event that happened. And so I'm going to talk about affective events as activities or states that have a positive or negative effect on the person who experienced the event. So positive events are things that are desirable for people or beneficial for people, and negative events are undesirable events or detrimental events for people. So some examples here are, I went to Disneyland, or if you tell me you just got engaged or adopted a new puppy, broke a swimming record, I'm going to assume you're probably happy about these events. It's not guaranteed. It's possible you went to Disneyland and had a horrible time. But we can think of these as sort of priors. So we talk about the positive or negative direction of an emotion as polarity. So emotions and events in this case have either positive or negative polarity. And I think about these sorts of the polarity of an event as being a prior polarity. So the default is, I would assume, if you tell me you went to Disneyland, got engaged, adopted a puppy, I'm going to assume by default that you're happy about that unless you tell me otherwise. And on the flip side, if you tell me that your house burned down or that you just dropped your iPhone in the toilet, these things really do happen if you extract events from Twitter, or that your puppy ran away, you broke your arm, I'm going to assume these were not events that were desirable to you. And so you might be wondering, why do we care about this? And there's actually a variety of reasons why we want to recognize these affective events in text. So I'm going to go through a couple of them to help you appreciate the many different ways actually that they play a role in language understanding. So first of all, it's an important part of implicit sentiment analysis. So some of you may know there's been a lot of work in NLP on trying to recognize positive and negative sentiments and more specific emotions in text. But most of that work has focused on recognizing explicit expressions of emotion. When someone explicitly says that they were happy or sad, maybe they use a complex expression like someone was driving them up the wall, but still they explicitly stated their emotion. But there's an awful lot of text where we just assume that someone's in a positive or negative emotional state, even though they didn't explicitly tell us that. So we call this implicit sentiment analysis, and affective events are one of the common reasons for implicit sentiment. Another reason has to do with narrative understanding. So I'm very interested in trying to understand narrative stories about actions that happened. It can be fiction or nonfiction. So it might be a fictional book, or it might also just be a news story talking about events that happened in the world. And an awful lot of narrative stories fundamentally revolve around problems and goals. So if you think about a book or a movie, it's really, really boring if nobody ever encounters any problems, right? Everything is just always good and happy all the time. So plots are often driven by problem situations that get resolved or don't get resolved. And if you think about what is a problem, it's a negative event, right? It's an event that you're not happy about, and often you want to try to resolve it into a situation that you are happy about or is at least neutral. And so goals are often ways in which you try to resolve your problems. And this has been recognized for a long time. back into the early 1980s, at least. But I also want to mention that I really started to appreciate this aspect of language understanding again in the early 2000s. This was some joint work with Amit Goyal and Hal Domé, who were here at the time. We were working on Aesop's fables, which many of you probably know, these very simple little stories. And there were almost no explicit expressions of emotions, but there was an awful lot of plot that often revolved around animals too, by the way. But there'd be these simple little statements in the text, like the lion saw an antelope on the hill. You've got a whole story in your mind, right? From that one sentence. And sometimes it would be a little more explicit. You know, the lion was hungry. You know, he saw an antelope on the hill. And so your understanding of these plots is driven by a recognition that being hungry, for example, is a problem. Being chased is bad. Being eaten is bad. But doing the eating is good. Capturing something is good. So the lion chased and caught the antelope is very good for the lion. It's very bad for the antelope. But again, there's no emotion expressed here. You need to understand the polarity associated with the events from the perspective of the characters. And so these are really common. You know, in our world, we talk about getting hired, getting fired, getting promoted, getting tenured. These are all examples of affective events in academia, for example. Okay, and this taps into other work related to question answering and summarization as well. There are all sorts of natural language processing tasks that are related to narrative understanding. And another point I want to make is that I sort of stumbled upon these a few years later again when I was working on sarcasm recognition with my students. We were looking at tweets, trying to figure out if we could make any headway on recognizing sarcasm by pulling out tweets that had a sarcasm hashtag. And my students came to me one day and said, hey, we've noticed a whole lot of tweets that have kind of the same pattern. And they described it as having both positive and sentiment and negative sentiment, but it wasn't exactly that. The tweets look like this. Oh, how I love being ignored. I so love working on Saturday. Absolutely adore it when my bus is late. Thoroughly enjoyed shoveling the driveway today. And so what you have here is a positive emotion word, love, adore, enjoyed, next to what's really a negative event, not another expression of emotion. But your knowledge of the world is that, you know, most people do not enjoy being ignored. They don't enjoy working on Saturdays. They don't like it when the bus is late. And shoveling snow is not really recreation. And so it's the juxtaposition of the positive emotion word with an event that we know is stereotypically negative that produces the dissonance that creates the sarcasm. And so again, I started thinking, recognizing these affective events can really play a role in sarcasm recognition. And so we did a little attempt at learning affective events back then as well, but it was really kind of a preliminary approach. And finally, I just want to mention conversational dialogue, which is, I think, one of the most obvious uses for this. There's so many conversational systems these days, Alexa, for example. And, you know, if somebody says to you or says to the system, I got a new job, and the system says, so sorry to hear that, right? You're going to say, that's a really dumb system. Or the other way around is even worse. You know, my house burned down. Congratulations, that's wonderful news, right? That's a really bad conversational system. So for any sort of conversational application, we really need our systems to understand the implicit emotions behind events. Okay, so today with that background in mind, I want to talk a little bit about two avenues of work that we've been doing. First of all, I'll just explain to you some of the background in terms of the data we're using and the way we're representing events. And then talk about this weekly supervised method that we put together to try to assign affective polarity to events. And then finally, if there's still time, I'll talk a little bit about how we tried to go beyond just this core sense of positive and negative polarity and try to characterize the reason behind the positive and negative polarity a little bit, at least. And this work that I'm going to talk about today mostly was work that I did with Haibo Ding, who was a PhD student here, graduated a couple of years ago. So just to give him proper acknowledgement for his work. So the data set that we were using is this Spinner data set that was released by the ICWSM folks, if you know that conference. There's actually 2 different data sets, 2009 and 2011. That would be my dog. Hang on one second. Okay, so yeah, it has a tremendous number of blog posts, 177 million blog posts. And we wanted to work with social media data of some kind because we think that has just a ton of information about ordinary, everyday events in life. But most of these blog posts were not really stories of personal events. There's a lot of advertisements and, like cooking blogs and stuff like that. So we used a personal story classifier that had been created by previous researchers, Andrew Gordon and Reed Swanson, to pull out. They'd worked with the same corpus, and their classifier pulled out posts that looked like they were probably more personal stories by looking for things like personal pronouns and such. So we just used their classifier as a filter, and that left us with 1.4 million blog posts that mostly we think were personal stories. We did part speech tagging, named entity recognition, parsed the corpus. This work, again, dates back to about 2006, 2007. So these tools were the tools available back then. And we got out 571,000 unique events that had a frequency of at least 5. And we worked with that data for these results today. So how do you represent an event? Well, we tried to find some approach that could adequately capture the gist of the event without being too detailed. What we decided upon was a 4-tuple that captures the predicate, which is the verb phrase, essentially describing the action, the agent who performed the event, the theme, object involved in the event, and one prepositional phrase, that whatever the closest one is that attached to the event. This was all done heuristically. We didn't do semantic role labeling, but I think it was reasonably okay. So an example on the left here, the active voice example. When we have a verb phrase in the active voice, we just pulled out the subject as the probable agent, the direct object as the theme, and used the head nouns, the lemmatized head nouns as the words in that 4-tuple. So they had a big dinner party would be extracted out into this tuple that's just they have party. If we get a passive voice construction, we would pull out the subject to be the object of the event and look for the by PP with the agent role to be the agent of the event. So the man was killed by police would be extracted into this tuple, police kill man. And I want to say for a minute why we included PPs, because a lot of work with events just uses what we call SVO triples, subject, verb, object triples. But I think prepositional phrases are the most underappreciated syntactic constituent. They really can make a big difference sometimes. And we felt it was important to include at least one. So we pulled out, like I said, the closest one. And here's a good example. The verbs are often weak. They're just underspecified when you only look at them. So he went to the beach is a very different kind of event than he went to prison, right? Just he went doesn't tell you a whole lot of information. He got into college is very different from he got into an argument. And so these prepositional phrases, I think, are very important to include. The next thing we did is we did a human annotation study to try to get a sense of how common these affective events were, because we weren't sure, honestly, when we started this work. So we pulled out 1,500 of these events randomly and had 3 human annotators assign polarity to them. In the end, we got fairly good kappa scores. And here's the class distribution in this table. So it turned out that 20% of them had positive polarity, 18% of them had negative polarity, and 62% had neutral polarity. And you might look at that at first and say, well, the majority are neutral, which is true. On the other hand, we were actually really surprised that nearly 40% of events have positive or negative affective polarity. And that was far more than we expected, actually. And it gives you a good sense of just how common these affective events are. They're truly everywhere. Okay, so hopefully that motivates the need to really try to recognize the polarity of events. So how did we do that? Well, my student Haibo Ding and I created this learning model that we call Semantic Consistency Learning Model. And the intuition behind it is that there are lots of sentiment tools out there. There's lots of lexicons, semantic lexicons, or sentiment-related lexicons. There's various classifiers and other tools that are out there that often use the lexicons as features. And so if you give these tools events, they can label some of them. Sometimes they just contain some of the words related to the event. I mean, the lexicons do. But also sometimes an event is expressed with an emotion. It's very common to express your emotion explicitly while you're mentioning an affective event, right? So the flu is a negative event for most people. And you might say, not just I got the flu, but I hate the flu, or I hate having the flu. So you do find these things together sometimes, in which case the existing sentiment tools can recognize it. But you also have words that have the implicit sentiment baked into the meaning of the word. So I guess it's not really implicit anymore, even though you don't think of it as an emotion word. So like celebrated, right? That is a word that's likely to be in sentiment lexicons, because what does it mean? It really doesn't tell you much, actually. It just says something happened because I was in a good mood, right? So it really does capture sentiment, even though it's expressed as an event, and the sentiment tools can recognize these things. So the idea behind our approach is to take advantage of the existing tools that are out there for recognizing sentiment to do an initial labeling of these events. But it's going to be noisy, right? These tools are far from perfect, even in the best of cases. Sentiment is quite a hard problem still. And also it's going to miss a lot of cases. That's really where we're at, that there are a lot of events that we know the sentiment resources cannot recognize. So we're going to create this graph structure of events with semantic relation edges that it's initialized with the existing sentiment tools, and then try to do this iterative learning to propagate polarity based upon constraints across the relations. Okay, so they're not really constraints actually, but they're heuristics, strong heuristics. So the three types of consistency that we want to try to enforce in the graph structure are that one, events that are semantically similar will probably have the same affective polarity. Okay, so if somebody tells you they got fired and another person tells you they lost your job, it's not exactly the same thing, but it's pretty close. And if you know that getting fired is bad, you can probably assume that losing your job is also going to be bad. Okay, so we're going to use that intuition to help with the learning. And the corollary of that is that events that have the opposite meaning will often have the opposite affective polarity. So if you know that winning is bad, for example, and then somebody says we did not win, you can assume that it's undesirable to not win. So we're going to try to make sure that events are consistent in this way as well. And then finally, event expressions have components, right? There's the predicate, and then there's also an agent and a theme and a prepositional object. And often, most of the time, all these different components are consistent, right? It's pretty unusual to have both a positive and a negative thing in the same event expression. It can happen sometimes, but again, it's fairly rare. You do get neutral things in there. Some of these components may be neutral and the others have polarity. But what we wanted to make sure is that we hopefully most of the time have the same polarity if it's not neutral. Okay, so the learning is going to try to push these things, the individual components, to have the same polarity as the event as a whole to the extent that it can. And neutral words will just occur with everything. And so they won't be able to be pushed too far into one polarity. We hope. That's the hope. And so we set up this graph where the nodes represent the events, the event phrases, these tuples. And we also have component nodes that represent each of the constituents inside the tuples. And every node in the graph has a polarity distribution, right? So it's got positive and negative neutral. It's a vector of size 3 with the 3 polarities in there that have to sum to 1. Okay, and so we're trying to just represent the degree to which this event is positive, negative, or neutral. And then the edges represent those 3 types of semantic relations that I described: event similarity, event opposition, and the event component relation. And we use word embeddings here to represent the degree of similarity between events. Since this work was done quite a while ago, we used glove embeddings at the time. I'll tell you a little bit later how we're using more recent stuff now. But that's the idea here. And we used a little trick for negation to deal with the opposition. We kind of looked for certain types of negation structures and created these opposition edges when we saw one event and another event that was basically the same, except that one of them was negated. So this was all put into an optimization framework. And the goal here is that we want to try to optimize for consistency, or basically minimize the inconsistency across the graph based on these polarity vectors. So we have one dimension of this objective function that looks at the similarity of events. Okay, so we're just looking at the KL divergence between the polarity vectors associated with the events, and the degree is captured by the similarity of the word embeddings. The event opposition component of the function does the same thing, but there's an exchange matrix that tries to make sure it's in opposition. And then we have a component in the objective function that tries to enforce the similarity between an event and one of its components. And we have two parts here only because KL divergence is not symmetric. So we have to look at that from both directions. And there's the whole objective function is here. So three of those components are what I just mentioned up top. And then the two on the endpoints are just priors, where we also have components in here that try to make sure we don't stray too far from what the original initialization values were. Okay. And that actually turns out to be important. Otherwise, things kind of go haywire across the whole graph. So we do this optimization over the whole graph, which tries to minimize the inconsistency based on these different relations. And that changes the polarity values for the events iteratively until everything converges.
So can I ask what the H is in the event opposition, or is that typo?
That's the exchange matrix that tries to make sure it's reversed.
Oh, okay.
Yep. Yep. Okay, so how well does this work? And there's more details about all this stuff in our papers if you want to dive into it. Well, the first thing we did is we wanted to get a sense for how well the sentiment resources do on their own, because that's used for initialization of our method as well. And so we did actually a ton of experiments with many different resources and many different combinations. I'm just going to summarize the most relevant things here. The best lexicon we found was the MPQA lexicon, which ended up getting an average F-score of about 64. The best classifier we found was developed at NRC Canada, and that got an F-score of about 65. We also tried contextual methods that applied the classifiers to the sentences that were extracted that mention the event, and that got an F-score of about 58. But we also tried combinations. We really wanted to push these sentiment resources as hard as we could. And we tried combinations of these, and the lexicon and the contextual method are complementary. They're really using kind of different data. And so when you use them together, then you get an even better score. So we call this the combo method. It's a high-tech term, combo, that uses both of these resources. And that's going to be the starting point that we're hoping to improve upon. And so these are the results here. That combo method got an F-score averaged over the three polarity values of 66. And then we evaluated our semantic consistency model using each type of relation added one at a time. So we start with just the semantic consistency part of the objective function, and that improves things to about 68. When you add the opposition relations in, you get up to about 69. And when you add those component relations as well, you get up to a little more than 71. Okay, so overall, this model improved performance over existing resources from 66 to about 71. But that's not really the whole story. When we looked behind the scenes at the individual recall and precision, and to those of you who know me, you know I preach constantly about this. Don't just look at F-scores. You've got to look at the individual recall and precision breakdowns. You really get a better understanding of what's going on here. So here we have, for the combo method, which is the sentiment resources and our semantic consistency model, we've got the recall and precision over positive polarity, recall and precision over negative polarity, and recall and precision over the neutral polarity. And what you see here is that recall really didn't change that much, but precision has really improved. Right? So the positive polarity precision went from about 68 to 76. Negative precision went from 56 to 70. Okay, and that affects what happens in the neutral. But basically, you just clean things up, and to a dramatic degree. We don't see, precision go up, 8, 10 or more points very often. So it really had a huge impact on the precision of the labels that were assigned. And from this, what we did is we actually produced an affective event knowledge base resource that's available if anyone wants to use it. And we just pulled out all the events that have positive and negative polarity after this optimization procedure is finished. And there's 2 ways that I recommend people use it if you're interested. You can just label each event with whatever the highest polarity is in its vector, and that's sort of the default. There's about 175,000 event tuples in there now. And this is the recall precision breakdown for those events. But the other thing you can do, which I actually recommend probably, unless you really need to maximize recall, is to only use the events where one of the polarities has a value of at least 0.5. Because otherwise, some of these vectors, one polarity is 0.34 and the other one's 0.33. There's really not that big of a difference. But if you set that threshold to be 0.5, you get fewer events, although it's still more than 100,000. So it's still a substantial resource. But you can see the precision is much higher. Now you get, when you do get a positive event, it has over 90% precision, or 90% and 80% precision for the negative events. So that resource is available off our webpage if anyone wants to use it. But one more comment, and then I'll switch gears a little bit here. This resource is a little bit hard to use. We got a little frustrated ourselves because you have to take these event tuples and parse your data and match the parsing against the tuples, and it's just a little tedious. And we also were curious to see how some of these newer NLP models would do for this kind of task. Because again, things are moving so fast in the NLP world. GLOVE now feels like something from the 1800s, right? It's crazy. And so I'm not going to mention much about this now because it's kind of late breaking stuff, but we have a new system now that we haven't even finished this paper yet. It's been accepted to EMNLP this year, but we're still working on the camera ready version. But we trained up an affective event classifier by fine tuning the BERT transformer architecture, if you've heard of that. And it turns out that works quite well. Not surprisingly, BERT makes everything better, right? And we also added to that a discourse enhanced self-training method that further improves upon BERT's results by utilizing some unlabeled data as well. And this is all work that we did on Twitter. We actually annotated a new data set of affective events found in tweets. And you can see down here the results that we're currently getting. So the supervised row is what our AFBERT system does. That's just BERT fine-tuned for our task. And we're up to about a 76% F-score now. If you do vanilla self-training as a baseline, it helps a little bit further, but not too much. And our discourse enhanced self-training improved things a little bit more. So we're now at about recall and precision of about 80% roughly for both recall and precision. And that's much easier to use. That's half the story here. You don't have to go matching event tuples anymore. You can just feed your event phrase into the system and get a label out. So we'll be releasing that soon too. Any questions about any of that before I switch gears a little bit?
So I've got a question. So I'm curious, like when you had the 3 human annotators give you annotation on this, what was the self-consistency of the, like if you've gotten to 79%, how close is that to how humans are able to do this?
Yeah, that's a good question. Yeah, it's hard to say. I can't say for sure. I mean, there's some people who might argue that's the upper bound. And it's certainly, you can view it as the upper bound of what we could measure, because we can't expect more consistency than they do. But on the other hand, those are pairwise kappa scores, because anyway, and we do use the majority vote over 3 annotators to get these labels. So I think the human agreement actually is a little better than that in the way that we've acquired the data. And if you had more money to spend on Turkers, you could get agreement across, right, 20 people. So I'd say it's somewhat higher than that probably, but I can't say for sure. It's a good question.
I have a quick question.
Sure.
Just 2 questions. The research you're doing, just curious, is it only limited to English, or can you expand it to other languages too?
Yeah, right now it's pretty specific to English because of we have got a parser underneath all this to generate the event tuples. And that's highly specific to English. Now there's parsers for other languages. You could certainly build this model for other languages. But extracting events out from other languages, languages that are similar to ours would probably be pretty straightforward, but languages that are very different might be different. Yeah, it's hard for me to say.
So like, can you extract it from like German or like Dutch or something?
I mean, I'm sure you can. I mean,
oh, okay.
Yeah, the question is these tools that we're using here, you'd have to plug in your a brand new set of tools for those languages. And I don't know how, what I was getting is I don't know how straightforward the mapping would be for things like the heuristics that we use to find the agent and the theme. I think that's probably pretty specific to English. Now, there may be good tools to do that for other languages. I just don't know for sure.
Okay. Another question is, for the research you're doing, can it understand like figurative speech, or is it only limited to like literal?
Yeah, that's a great question too. There's a lot of figurative speech out there. We're not in any way trying to recognize figurative speech. And so I think the answer is it's probably going to, I mean, I'm guessing a little bit here, speculating. It's probably going to assign the polarity of the most general meaning, but that may often be consistent even across like metaphor, but not always. So for example, I'm thinking of a case like exploded, right? Where it can be a literal event like a bombing, right? That's a negative event. I don't think many people want to be bombed. You can also use it as a metaphor, but I think the sentiment polarity will be preserved even in the metaphor, right? So if you can say the discussion exploded, right? I don't think that's a good thing typically, although your mileage may vary, right? So, but this system isn't distinguishing. It's just going to come up with a polarity for explosion events across the set of explosion events that it sees. But this also taps into an important point, which is that it depends what you train it on, right? So if you trained it on news stories, almost all the instances of explosion are probably going to be bombing events or similar things. If you were to train it on, let's just say, an argumentation courses, you'd be swamped with probably the more metaphoric uses of explosion. Did that answer your question? Kind of.
Hey, Alan, this is Lynn Bacon. This is really great stuff. I was just thinking about inter-rater reliability. You know, there's a way of measuring reliability of multiple raters at once. I think Krippendorf's alpha is one of them.
Yeah.
The other thing I'm kind of wondering also is like, how culturally dependent is this? You know, is it possible that I mean, I know we kind of have to, ceteris paribus, we have to kind of hang whole differences in expressive language differently, but I'm wondering if at some level kind of the affect, at the kinds of events that generate different kinds of affects may vary quite a bit across cultures.
Yeah, so getting to the first question, yeah, Krippendorf's alpha we look at occasionally, but I almost never use it, honestly, because I think, especially for tasks like this, where you're never going to get agreement in the 90s, it's nearly impossible to get good agreement across everyone. But I don't think that's necessary because we're ending up with majority vote anyway.
Yeah.
So I think it's my personal view that these pairwise things, you can also generate, these ranges of all the set of pairwise agreements that paints a pretty good picture of the variance across pairs.
Yeah.
So I just personally prefer it.
I like saying it because it reminds me of a silly movie with Richard Dreyfuss and Jenna Elfman.
It's as good a reason as
Well,
any.
it's really an apocryphal science story. It's about a guy who became famous by making up a tribe, right? Anyway.
I should look into it, I guess.
Yeah, I don't know if it's a good use of time, but it's a really rotten movie. Anyway, I'm sorry. Go ahead.
But yeah, the cultural aspect is a very good one, for sure. I mean, there are definitely things that the polarity varies across cultures. And there are also events that have mixed polarity. We found them to be, we actually initially thought about labeling those as well. We found so few of them, we decided not to. But the one that stuck in our craw is, for example, pregnancy, right? That I think it's often a very positive event, but there are subcases where people are not happy about being pregnant. And so I think in reality, it is going to have this mixed polarity.
Yeah, there's sort of good news, bad news events, right?
Yeah, that's right.
Yeah.
Yeah,
really interesting. Really interesting.
Thank you. Any other questions before I shift? Okay. So the other line of work related to this, I thought I'd talk about today a little bit is trying to go beyond this positive and negative polarity. I mean, that's really useful. And for some applications, that may be all you need. But from a language understanding perspective, I kind of want to know more. I'd like to know, why is this negative? And in what way is it negative? What causes the positive or negative polarity? And so we followed on that work, my student Haibo and I, by looking at human needs categorization as a way to try to further categorize these different types of events. So I don't know how many of you are familiar with these. I wasn't familiar with it before, but there are these human need theories in psychology that have been developed to try to explain the reasons behind the motivations for people, the most common reasons. And I think the two most well-known one is something called the Maslow's hierarchy of needs, and also this theory of fundamental human needs by Max Neef et al. And they're really interesting to kind of look at because they kind of get at what people care about the most, what they get very upset about if they don't have, or what they try to obtain, or what makes them feel most satisfied, and so on. And our hypothesis here is that most affective events have positive or negative polarity because they satisfy or violate one of these basic human needs. So that's what we explored in this work. So let me tell you the human need categories that we ended up using. We looked at those existing theories. We're not using either one exactly as it is. We kind of tried to distill out the most core elements that were consistent with those theories and that we felt were fairly common in our data. And one of them is physiological needs. We have really strong needs just based on our body. We need sleep, we need to breathe clean air, we need food, we need water, and so on. So those are physiological needs. There are also needs concerned with health and safety. We don't want to get sick. We don't want to have, body parts broken. We don't want to be in any sort of pain or dangerous situation. So if you, even like something like, seeing a spider, why does it scare people? Because they're worried for their safety, right? There's leisure and aesthetics, which is described in these human need theories, that they claim we really need to have some leisure time, some recreation, and our appreciation of aesthetics gets lumped in with this. So why do you play basketball, or go to a concert, or go to a museum? They would all sort of fall into these categories, that one category. Humans are social creatures. We have a very strong need for social interaction, which is why we visit with people, we go to parties. If you look at Twitter, it's pretty sad. There's an awful lot of negative events with people saying, I have no friends, and various statements like that. So all of those go into the social bucket. Finances, we have a need to make money, to have enough resources, to obtain possessions. So all things related to kind of money and possessions it's really finances and possessions category. They fall into there. So getting a job is a positive event. under this category, but your laptop breaking or dropping your iPhone in the toilet, those are negative events for the finances and possessions category. We also have a very strong need to learn and just to maintain a healthy mental state. So stuff related to cognition and education falls into this category here. So learning a new skill, learning how to ski is a good thing. Forgetting things, you can't remember something, that falls into a negative cognition event. And then finally, events can also be positive or negative because they allow you or prevent you from having freedom or accessibility to things. So we saw this a lot on Twitter, less on the blogs, but things like I'm stuck in traffic. Nobody likes being stuck in traffic. It's because you're constrained. Or for us academics, I'm stuck in a meeting, right? We say this all the time. When the meeting finally ends, all right, that's a good thing. And so everything kind of related to freedom and accessibility falls into that last category. So we settled upon those to get things going. And again, we did a human annotation study to look at the prevalence of these categories and also how many fell into those categories at all. So we took the affective events from the manually annotated pile that we'd done earlier, and there were 559 of those, and labeled them again for these specific human needs categories. And we found out that 58% belong to one of those categories, but that's a little misleading because we also found a lot of these events were just straight up emotion expressions, which is probably why the initialization worked well in the earlier work. But if you eliminate the cases that didn't really describe events, just emotions straight up, then 78% fell into one of these categories. So there's still some that don't match up, about 20% or so, but 4 out of 5 did fall into one of these categories. And here's the distribution. You can see, again, there's a big pile of just straight up emotion expressions, but the really common ones were social and leisure and health. All of those were pretty well represented. And the others were smaller, but they were there. And we saw quite a bunch of physiological, finance, and cognition. The only one we saw very few of was this freedom category. But again, I think that we saw a lot more of that in Twitter for some reason. I don't know why. It would actually be interesting to study these in different forums. And here's some examples of just the events that we found for each of these categories. For the physiological, things like your pizza arriving was good. Getting hungry was bad. If your ear feels better, that's good. If your face looks pale, that's bad for health. For leisure, watching, I know some people like Hellboy 2, that wouldn't be me, but apparently it was popular in these blogs. But if like a sports game is rained out, that was bad. Getting married was good. Being confronted is bad for social. Getting a new laptop is good. Getting unemployed, becoming unemployed is bad. Cognition, memory is vivid was a good one. Memory not serving you was bad. And then again, these straight up emotion expressions, it's actually very hard to tease apart emotion statements and events just from syntactic analysis. So that's why a lot of our event tuples were just straight up describing events like my heart feels happy or I am scared. And we did have quite a few in this other case too. So I think there's future work here to kind of dive into that and look at them more. Just 2 examples. In one of the positive events we saw, we are legal, which our annotators thought was a positive event. It's really a state. I'm not sure how to quite categorize that. A lot of the others on the negative side were just really vague. So it not work for me. Something happened that you're not happy about, but it's just too vague to know what happened, right? So you can tell the sentiment, but you can't really characterize the event.
I have a question.
Sure.
Yeah. So in general, like I was thinking, like this affective events, like some of these like are somewhat more related to common sense. Like, for example, our pizza arrived. So this is like a common sense kind of thing. We will never write like our pizza arrived, I feel happy or something like this. But this has a positive annotation associated with it kind of thing. So like what's your thought on like connection with this common sense and this affective events? I always thought of this problem like where these two things are somewhat connected and like where they are separated?
Yeah, I'm not sure, honestly. I mean, I think that definitely richer semantics would help. So knowing, just being able to recognize that something is a movie like Hellboy 2, right? Or a book or whatever, laptop is a physical object, that would help you for sure. And in fact, I'll mention, Haibo did a little thing recently that showed that that helps. I mean, there are second order inferences that probably tie into what you're saying, right? So something like, I'm not sure I can think of one off the top of my head, but something like going to the supermarket will get you the food, right, to satisfy your hunger need. But getting the food is the positive event. I'm not sure going to the supermarket is positive. I think that's neutral. So, so I don't know. I think there probably is some effect there, but yeah, I don't have a good sense of exactly what types of common sense knowledge would matter most.
I have a follow-up question real quick.
Sure.
So in like this example where it says it not work for me, are you considering that it is in like the comments section of Twitter and relating to the previous tweet, or are you only taking like the head tweet in that regard?
Oh, this data here is still our blogs data. Yeah, I'm actually not showing any of our Twitter data today. But yeah, so there's no, I don't think there are any comments. It's part of, these blogs vary in length, but most of them are probably a couple paragraphs. So it's somewhere in the paragraph, yeah. Co-reference resolution would definitely help. But those of us in NLP know that's another really hard problem in its own right. Okay, so let me keep going here. It's also interesting to look at the polarity distributions across the different categories because there is skew. So maybe unsurprisingly, the leisure category was mostly positive. 87% of the time when people mentioned a leisure activity, it had positive polarity. The cases like a game being rained out were far more rare. And also social skewed pretty positive. 68% of social events were mentioned in a positive way, about a third were negative. There's a bunch in the middle. If you look at the bottom though, you'll see that physiological and health events skewed pretty strongly negative. People don't talk about their health very much when it's good. I think that's the takeaway here. And so, and similarly with things like physiological needs, you don't walk around saying, I'm not hungry, right? Too much. But you will say things sometimes like, I got a good night's sleep, right? So it's not impossible, but it's more common for people to talk about those types of events when they're negative. Okay, so how do we solve this problem? Well, we looked at a couple different ways. So I'm just going to walk through these fairly quickly in the interest of time here. We just did a baseline using a lexicon called Luke, which was developed by James Pennebecker at UT Austin and his folks. They're well-known psychologists who created this, this dictionary called Luke that has words tagged into certain categories that relate to categories that matter to psychologists, let's put it that way. And so we could kind of align our human needs categories with some of the categories in the Luke lexicon and use that as a baseline. If we found any of the words under like a health category or a leisure category, then we'd assign a label that way. We also trained up two different kinds of supervised classifiers. One type of classifier was trained just on the event expression itself, just those words. And the other one was based on the context around the event expression in the corpus, the sentences in which the expression occurred. And then we also tried two fairly straightforward applications of semi-supervised learning to see if we could further improve with unlabeled data. We just did straight up self-training and co-training. So for the supervised classifiers, we tried a whole bunch of experiments. Again, logistic regression, SVMs, recurrent neural net. We tried both bag of word features and event embeddings, again, using Glove a couple of years ago. And the best performer was logistic regression with word embeddings. So that's what we use for the rest of this talk. The event context classifier, again, the intuition here is that the event itself is really important, obviously, but also we expect the context around it to probably be consistent in many cases with the polarity. You know, if you say that you broke your leg, there's probably other words in the sentence or the sentences around it that are also going to be negative. And so maybe we can learn from the contexts. We wanted to explore that. And so, for example, you find sentences like, I broke my leg when I was hit during football, and being hit is bad. While studying in LA, I had a car accident. I broke my leg. The word accident probably has negative polarity in many lexicons. My leg still hurts a lot because I broke my leg. The word hurt should have negative polarity. So we explored that avenue as well. And again, we tried both bag of word features and word embedding features. And so our setup here now is that we use the manually labeled events as training data, and we trained up one classifier based just on the expression as input, another classifier based on the sentences extracted from the corpus that mention those events. And then we also tried putting that into this iterative loop that learns from unlabeled data. We have plenty of unlabeled events in this large blob corpus. And so we can have each classifier label the unlabeled events that it feels most confident about and add those label data into the training set and then retrain the classifier. And because these two classifiers are using different types of data that are really complementary, the words in the event expression itself versus the context around the words in sentences, it's a fairly traditional co-training setup where the events that one classifier can label may then be useful as new training data for the other classifier. So the new labeled examples go into the training pool, and then both classifiers are retrained in an iterative fashion. Like that. So how did this all work? Oh, and we also did straightforward self-training of just the single classifier as well. So the Luke lexicon got us an F-score of about 38.6. This is averaged over all the human need categories. The contextual classifier worked better than the Luke lexicon, but not too well, 44 F-score. The event expression classifier got us up to about 55. Self-training with the event expression classifier gave us another 2 points of performance, roughly. And then the co-training model that used the event expression classifier and the context classifier in this co-training architecture got us up to about 62. So the co-training really did help. And 62% F-score is not too bad because this is a many-way classification problem now. And I'm also just going to briefly mention that in 2019, Haibo followed up on this work and created a little neural network to train up with small amounts of training data and got even better performance. There was semantic class learning was kind of embedded in that process. I'm not going to go into that, but you can look at this paper if you're interested. And this is the results where we are now with that. So you can see precision and recall for each of the categories here and the F-score, and it varies a lot, right? Some of them are fairly easy to recognize, like social, we're doing pretty well. Physiological is not too bad. Finance is surprisingly hard. We're only at 48% recall on that one. Health isn't as good as I would like it to be. For finance, I think there's so many different kinds of possessions that has a lot to do with why it's hard to learn. But there's definitely more work to do here. So that's really all I'm going to say today. I've been working on this direction of affective events for a while now, obviously, and I'm still constantly fascinated by it. I think it just ties into so many different aspects of language understanding. It's a very rich area to work in, and there's more work to do. You know, these systems are still missing a lot of events, but we've made a lot of progress. I think we can recognize them far better now than we could 5-6 years ago. And human needs categorization to me is also really interesting fundamentally. I think we've only scratched the surface of that, but I really like the idea of trying to understand more than just positive and negative polarity. It's very coarse. I'd like to understand how it affects people in the real world. But there's more work to do. So if you're interested in this direction, that'd be great to see more people work on this topic. I think recall is still a really big problem for affective polarity. We're just missing, especially positive events for some reason. They're harder to find than negative events, I think. I mean, yeah. So, and the human needs categorization, again, we've really just done fairly simple things with that so far. I think there's more that could be done there. And I've been really happy to see that other people have found the human needs category stuff interesting too. I've discovered there's a bunch of other people out there who've been thinking about human needs categories in NLP. And we're happy to know that they weren't alone. So, so let me end it there. And are there any questions? Comments?
Yeah. So, so great talk, Ellen. So if anyone has questions, please raise your hand in the participants window, and I'll try and keep track of who's there first.
Yeah, I have a question. If I can go, nobody. Yeah. So, this is a new kind of, like, when I saw this, like, it's look like a very new and novel task, and I see where it is naturally coming and what's the usefulness of this. The thing is, like, you created data sets for basically starting with this task, and like there's a little bit fallback on something like these when you have to basically start with the, like, even the data set creation and all. And secondly is the scale issue. Like, for example, like if I want to run some very big neural network on this, like I don't have so much supervised data kind of thing. So what's your thought on this? Like, do you think like it is possible, like where the effort need to be done in this area? As you said, like it's relatively new and novel task and people are coming in this. So where should the effort, should we need more better data sets in these areas, or should we need more better techniques kind of thing for handling? Because yeah, what's your thought on this and where you think that community effort should go on? This is a very little bit broad level, but I think like this is true with when you ever come with something new and like limit it on that sense. So how should you approach those things? That's all.
Yeah. Yeah, those are good questions. I like to work on these new problems because I just like to see the community tackle new problems. But it's a big undertaking to define a new task and generate new data yourself. And I don't have the kind of money that like the LNAI people do to, you know, have 20 Turkers label 100,000 examples of everything. But you have, I don't know, I'm not personally, I've been doing research for a very long time in weakly supervised learning, bootstrapping, because I don't believe even today that the solution to all NLP problems is just annotate gobs of data. More data is always good. There's no question about that. But I just don't think that's the realistic solution for an awful lot of real problems. I also do a lot of work, for example, in domain-specific language processing, where you're really focused on a very specific subdomain. For example, I was talking to someone recently about working on safety reports for the mining industry, right? There's very specific vocabulary for miners. And what are you going to do? Ask them to label 1 million examples? It's just not feasible. So I like to see people work on semi-supervised methods that can learn from unlabeled data. I long liked that kind of work. And I think it's important because we just can't be labeling 1 million examples for every single thing we might want to do. And I think it really does inhibit people from working on a lot of these novel problems because they just feel, like you said, that they can't generate 1 million examples. They don't want to generate 1 million examples. They don't have the money to hire Turkers or to deal with setting up the Turking experiments. But I also think it's important to think about, and your instincts earlier were good, kind of think about the knowledge that would really benefit a problem like this. So for example, Haibo started thinking about semantic class. Recognizing semantic classes might help here, and that's where he got those improved results. If you can think about what kind of knowledge makes sense that, you know, as a human, I use this knowledge when I solve this problem. And so if you can inject it into your favorite machine learning system, I think those are very good directions to think in, that, you know, you can get improvements even, you know, without labeling 5 billion examples.
So I don't see any hands, but I have a question. So we had done some work on trying to understand the geometry captured by these word vector embeddings. And we had some luck of identifying a subspace which captured polarity. This was part of a kind of these other evaluation tasks. So it was not something we explored so just on its own. But so it was not as strong a signal as you'd find with like gender, where he and she define this very clear axis. So so without having explored it in depth, I was wondering what your opinion would be on of how much of this polarity, like, you know, if you can get up to here with your with these more specific techniques, and you can just find up to here in like the word embeddings, like how much you think could just be encoded in there versus kind of these other more detailed approaches, and maybe some pitfalls that might be associated with that as well.
Yeah, this sort of ties in with Vivek's question, I think, about common sense, maybe. What other kinds of knowledge might you need to go beyond just the polarity? I really do think that polarity is kind of a second order effect here. That's why these events fascinate me. So if I say I'm tired, you know, there's an understanding of what that means to people. I don't think they're thinking positive, negative, right? I think they're thinking about the meaning of being tired or being exhausted. And so I would expect that these embeddings and other sorts of representations that you might imagine should be capturing what it means to be tired. And the polarity, like I said, is second order to that. But there's a mixture, right? And there are these things that capture both. If you say, and because so many of our words capture two things. So if I say I broke my leg, you know, I'm not saying my leg is now in two pieces, which is kind of the most factual way of saying maybe the same thing. The word broke has its own polarity built into it over time as well, but it's not really a sentiment. So a lot of these words capture both. And I suspect that's what the embeddings are pulling out for words that are not emotional per se. It's sort of like overloading a little bit. Anyway, I'm not sure, but I think there's many dimensions that come into play here. And I would hope that any system that learns good representations would eventually be able to pull out multiple dimensions that are in play here. I don't know if that's really answering your question, but.
Yeah, so great. So it actually gives me hope that there's a bunch of subtle information captured that we might not fully understand how it is captured yet.
Yeah, and isn't captured yet. I mean, I'm quite sure that even the best systems we have today are not capturing all aspects of meaning that they need to be.
Mm-hmm.
Yeah.
Great. So Lind? You're still on mute.
Muted?
I'm just miming. I'm not actually talking.
Oh.
No, I'm just kidding. Oh, yeah. Hey, so Ellen, this is great stuff. What you're thinking about capturing the degree of positivity or negativity at some point? You know, because right now we're classifying things maybe as neutral, positive, and negative. What about how positive things are or how negative things are?
Yeah, that's a great question. There are people in the sentiment field who work on degrees of intensity for emotion, and I think that's what you're getting at probably. It's definitely real, you know, and there's things that scare the bejesus out of you and things that scare you in a much more minor way. I was spooked is very different than I was terrified. Yeah, so I think it's worth doing that. I feel like for events, well, Actually, I'm not sure. No, I think it is worth doing. I mean, there's some events that are really life-changing and absolutely horrible, and others that are minor, and it would be good to capture that. The reason I was hesitating is because the degrees are hard. It's the extreme cases are easy, right? But there's so much in the middle that teasing apart small differences in intensity is hard. But I think at least some course categories of like, you know, low, medium, high intensity would definitely be useful.
Yeah, there's that issue of like how much of that information is really in text, right? As opposed to maybe it's an inference we make as language users, right?
Yeah.
So
Yeah.
because that for communication to happen, of course, there's a bunch of, you know, of motivating context and language knowledge we bring to bear, where text is basically a sparse representation of something, right? It's kind of a knowledge artifact, I think, is Aristotle or Socrates may have said. The other thing actually I've been wondering about is, you know, as I think about these needs and need states, in a sense, whether they're positive or negative, it's like a change in a need state, right?
Right.
So I wasn't hungry, now I'm hungry. That's not a good thing. So maybe it's the change that's negative.
Yes.
Something else I've been thinking about coincidentally, actually having to do with teaching students critical learning, is the importance of doubt. That experiencing doubt is supposed to be I guess a bad thing because it's something you want to reduce. And generally speaking, people like to reduce uncertainty too. Right. So maybe some of these things have an aspect of, you know, if it's a negative statement about health, maybe what the underlying cause or the value of that or the disutility has to do with the fact that it's creating uncertainty for whoever's expressing that thing. I don't know if that's anywhere in the data that we can ever pull it out, but that may be some higher level or a level of abstraction having to do with the expression itself.
That's a really interesting point. I like the way you're thinking about these things. Yeah. And it gets into this issue of there are some things that are mixed too, and context matters. So if you say that somebody is quiet, right, and sometimes that's a
context very important.
Criticism. All of this work we're doing now is independent of context, right? We're just looking at an event phrase and trying to assign a prior to it, but it'd be really interesting to, you know, recognize the cases when you go to Disneyland and had a terrible time, right? When you're getting these mixed signals coming in. And I also want to add that I totally agree with your earlier point about, you know, there's information coming from meta places too, but there is a lot in the text as well. So for intensity, for example, you know, if you tell me that you have pancreatic cancer, that's a whole lot worse than telling me that your nose is running, which are both negative health events. We saw noses running as one of our events, actually.
Sure. Well, in a sense, your background knowledge of that allows you to kind of have a prior for how intense that is, right?
Right. That's right.
Yeah, because the statement doesn't say I'm really, really worried because I've got pancreatic cancer as a statement of fact.
Yeah.
And then the inference based on your, you know, prior world knowledge and as a person who's a competent language user allows you to kind of make that inference.
Yeah. And Vivek, that might be a good example of where common sense knowledge comes into play too.
Yeah, absolutely. Thanks. Really great. I mean, really interesting stuff. Really appreciate it.
Oh, thanks very much.
Yeah, so great. So thanks again, Ellen, for a talk that covered stuff that was, you know, very deep and cool, but also I think accessible for everyone in this crowd. So great.
Cool.
So
thanks for inviting me, Jeff. Yeah, appreciate it.
Sure. So let's thank Ellen again. So
I have a question.
Sure.
Question. Yeah, this is actually not about the research, but just more about the class you teach. I have a question. So are you still teaching natural language processing, the class?
I am this semester.
Okay.
Yeah.